Hey everyone, in our previous video, we Dockerized a Django app for development. Today, we are leveling up. We're talking production-ready Docker files. Because let's face it, slapping CMD LAN server into a container isn't gonna cut it for real-world applications. By the end of this video, you'll have a battle-tested Docker file that is secure, efficient, and ready for prime time. So let's dive in. First of all, let's address the elephant in the room. Why can't we use the same Docker file from development? In production, we care about security. So we don't want to run as the root user. And then we also want a minimal image size. For example, this image size, if I do Docker image list, so this is my Docker image that I built last time, and this is 1.14 GB. So nobody needs more than 1 GB of development tools in production. And lastly, we can talk about performance. So instead of using CMD Python manage.py LAN server, we want to use a proper process management with tools like gunicorn or USWGI servers. So our Docker file today tackles all three. Let's break it down stage by stage. So I'm going to remove this and then let's use this one. So I'm going to go through it and explain. I'm also going to share the code at the end so you can be able to use this code. So this is our Docker file. A good starter question could be, have you ever heard of multi-stage builds? In the previous Docker file, we had only one build, but this Docker file, you're going to realize that as we go along, that this has been divided into stages. So we have this stage one where we build everything, and then stage two where we have the final image. You can think of it as baking a cake. So stage one could be the builder, where you mix all the messy ingredients. In this case, install all the dependencies, compile code, etc. Stage two could be the final image in this case as well. So this is our final image. In terms of a cake, that's now a beautiful frosted cake. And only what's needed is for it to be served. So let's look at this code step by step and understand the changes that we've made to make this production ready. So in this case, which is different from the previous Docker file, we have used Python 13, 3.13 Slim. In the previous Docker file, we did not use Python. We just used Python 3.13. But this Slim image only contains what's necessary for us to build our Docker image. And then we've included as builder just to rename this stage of build. So like in our previous Docker file, we have also learned this command make dir, which creates an app directory inside our container. And then after that, we're going to set that app directory as the working directory. After we've done that, we need to make sure that we have requirements to txt file, because when we're building our image, Docker is going to look this for these requirements to txt file and then install all the dependencies. So we need to have that. If you don't have that, make sure first of all you've created a virtual environment. If you don't know how to create a virtual environment, you can check my previous tutorials. But you have a virtual environment. Now, to create a requirements to txt file, all you need to do is pip. Once you've activated your virtual environment, pip, it has to be pip freeze, because you want it to freeze into a file. So it's going to be this hello and the file that you want to be created, .txt. So let me delete this file so you can see it being in your time. So I'm going to do that, and then you can see it has been created. And here you can see all these other dependencies that we're going to need to install in order to have the same application that we have created, or the same application, the same So these are all the requirements that we need or dependencies that we need to install in order to have this project working again. So that's what we're doing here. We are copying this into our container. Once we've done that, we want to learn pip install minus minus upgrade pip. This is going to upgrade our pip version. So this will help you avoid errors that come up, maybe saying there is a newer version of pip and all that. So that tackles that error. And then the next thing that we need to do is pip install minus minus no cache dir minus r requirements.txt. Now we are installing every dependence that was in our requirements.txt. Now, an important thing to notice here is we have used minus minus no cache dir. That saves us close to 50 MB by preventing pip from caching. So that's very important. But sometimes it also, if you have errors with your application because it's trying to install maybe uh, dependencies that were previously installed but they were broken, this makes sure that we don't have cache, so we're not installing from cache. All right, so let's go to the final stage or the final image. So first of all, raise your hand if you've ever run a container as root. I know maybe all of us have done that at some point in time, or maybe we're still doing it. Stop doing that. Because if a hacker gets in, they'll have root access. So this is the quick fix. So you have to create another system user. In this case, the name is app user. And then we are changing ownership of our app directory that we created in our previous stage and giving ownership to this app user. Okay, so this is what this command is doing. First of all, we are adding a new user, a system user called app user. And then we are creating a directory called app. And then finally, we want to make the app user the owner of this directory. So we are giving ownership to app user for this directory. This simple step is like putting a deadbolt on your app's front door. It's a security measure, a good one. And then after we've done this, we want to copy only what's needed. So we are copying. So after we've done this, now we want to copy only what's needed. Now the magic of multi stage pays off. From the builder, we only copy the installed packages. These are the installed packages and then the necessary binaries from this location. And then we are also copying the executable binaries, the necessary ones, into the next image. This leaves behind all build tools like GCC and Make that could be exploited. So our final image is lean and mean. So next, we want to make the app directory, the one that we've created here, to be the working directory. And then we are copying everything that is left from this location into our app directory. Once we've done that, we are also changing the ownership of everything that is in here and giving it to the app user. So the app user owns every single file in the app directory. Now, here we have two critical environmental variables. So these two critical environmental variables do two things. The first one is to prevent Python from writing bytecode. And the second one is used to disable output buffering. And then once we've done that, we want to switch from the root user to the app user. We're going to expose port 8000. And then finally, we are going to use gunicorn instead of python manage.py LAN server. And then here we've added three workers. There is some mathematics that would go in to find how many workers you need per CPUs you have. Like, I'm not going to go deep into that, but just know that we are using here gunicorn, which is a WSGI server instead of using python manage.py LAN server. And then what's important here for you to take note of is here we're saying we are saying gunicorn minus minus bind, and then we have included 000 so that we make this accessible to the external world. And then we are saying port 8000. We have added 3 workers, and then here we're saying main.wsti. So in your application, it would not be main, but what I'm doing here is I'm coming to this directory, which is main in my case, and then I'm going to this WSTI. So that's what I'm doing. So whatever you've renamed this main or this root for this main folder is what you are also going to name here. So now I need to build the image before we even think of learning it. So I'm going to say Docker build minus T, and I want to check the name. So we have Django API here. So I'm going to call this Django API as well, but I'm going to give it a flag of production. So we use the period to indicate that our Docker file is within the same directory. So let's build and see. Okay, great. So now the build process has finalized successfully, which is great. So let's check our image. To do that, I need to use the same command, docker image list. And then here you can see that we have this one, which was 1.14 GB. And then we have this one, which has been tagged production, which is 242 GB. Look at the difference, guys. Tell me this is not helpful. This is a Docker file that won't make your DevOps engineer cry. All right, now we can go ahead and learn it because some of you would be excited to know how you would go ahead and learn this Docker image. So to do that, what you need to do is say Docker learn minus p port 8000. So minus p stands for port. So we're going to say port 8000, and that's it. Let's just learn it and see. Okay, here we need to specify the Docker image that we want to learn. So in this case is my is Django API, and then which one? The one that has a production flag. Okay, so let's do that. And here it is learning. And if I go to check my Docker containers, let me show you inside here. Uh, let's see. So we have 13 seconds ago, this one, Django API production. It's running on port 8000. And we can check the images as well. So inside the images, we have this one, which was run 6 minutes ago, and it's in use, and it's the Django API. All right. So I'm going to go to the containers again and see which one is learning, which one is in use. This one is learning. So if I go and check this in my browser, so this is what's showing now. It says invalid HTTP host header localhost port 8000, and you know what to do to solve this. All you need to do is go in your allowed host and add this, build it again, and you have it running. So I'm not going to do this, but you know if this is happening, then it's building. If you know that if this is happening, then our Docker or our Django application is running if you've used Django before. So a few commands that would be helpful is if you want to run your container in a detached mode, then you can use the same command, but then use minus D here for detached. So this will run in a detached mode. You can see this. This is running, and this is the sort of the ID. So there you have it. So there you have it. A Docker file, like I said, that won't make your DevOps engineers cry. So smash the subscribe button if you want to see more of these videos, and add your comment below. What is your number one Docker pain? And we are going to talk about it. Thanks for watching, and remember, containers are awesome, but only if you build them right. See you next time.